This section is on similar triangles. Why similar triangles are important. Nearly every SAT test will have at least one problem on similar triangles. Also, if you plan to take differential calculus at some time in the future, you will have to know similar triangles to solve many of the word problems, especially shadow problems. In this section, you will learn how to recognize similar triangles, how to use proportions to solve for unknown side lengths, and how to solve word problems using similar triangles. What are similar triangles? Similar triangles have the same shape but different sizes. The ratios of all three pairs of corresponding sides of the two triangles are equal, and the pairs of corresponding angles are equal as well. How to recognize similar triangles. If two pairs of corresponding angles are congruent, the triangles are similar. Notice the two triangles on the right. Each triangle has an angle of 80 degrees. Those are the corresponding angles, and each triangle also has angles of 60 degrees. Because two pairs of corresponding angles are congruent, the triangles are similar. Another way of recognizing similar triangles is that corresponding sides of similar triangles have the same ratio. In this example, the two triangles in the diagram have corresponding sides with a ratio of 3. Other pairs of similar triangles may have another ratio, like 2 or 1/5, but whatever that ratio is, it must be the same for all three pairs of corresponding sides. Look at the triangles on the right below. Notice that EC in the larger triangle and BD in the smaller triangle are corresponding sides. That ratio of their side lengths is 15/5, which is 3. EF over DA equals 18/6 equals 3, and CF over AB equals 12/4, which is 3. Okay. Recognizing similar triangles, part 2. Look at the diagram on the right. If AB is parallel to CD, the two triangles are similar. Let's explain why. We can think of AD and BC as transversals of those two parallel lines, and thus the rules about alternate interior angles apply. And therefore, we would have B and C as alternate interior angles, and they would be congruent. A and D are alternate interior angles, and they are congruent also. Because two pairs of alternate interior angles are congruent, the triangles are similar. It will be very helpful to you when solving similar triangle problems to recognize what corresponding sides are. If A and D are corresponding angles, the corresponding sides are the segments between the two angles. Thus, ED and EA are corresponding sides. In general, corresponding sides will be part of the same line segment. Recognizing similar triangles, part 3. If segment AB is parallel to segment ED, the segments AC and BC are transversals. Angle CAB and angle CED are corresponding angles and are therefore congruent. For similar reasons, angle CDE and angle CBA are corresponding angles and therefore congruent. Because two pairs of corresponding angles are congruent, the triangles are similar. In example 1, use facts about similar triangles to find side lengths. To solve for x, set up a proportion. In this case, our proportion is 3/2 equals x over 4. Notice that we've set it up so that we're consistent in our proportions. The side length of the top triangle is over the side length of the bottom triangle in both of those fractions. We cross multiply and get 3 times 4 equals 2 times x. This gives 12 equals 2x. Dividing by 2 on both sides gives x equals 6. In example 2, solve for x. Find EC and AE. Again, we set up a proportion with 4 over 3 equals x plus 2 over x. And we have the longer side over the shorter side in each of those fractions that make up the proportion. We cross multiply. 4x equals 3 times the quantity x plus 2. This gives 4x equals 3x plus 6. Subtracting 3x from both sides gives us x equals 6. That's the length of EC. To find AE, we substitute into the expression for its length, which is x plus 2. Since x equals 6, we replace x with 6, and 6 plus 2 equals 8. In example 3, solve for x. To set up the correct proportion, it is necessary to recognize what the corresponding sides are. The corresponding sides are 4 and x, as well as 2 and 3. Remember, we discussed earlier that corresponding sides are usually part of the same line segment. The proportion is 4 over x equals 3 over 2. Cross multiplying gives 4 times 2 equals 3 times x. This simplifies to 8 equals 3x. Dividing both sides by 3 gives us a length that x equals 8 over 3. In example 4, solve for x. This problem is a little different. Notice that we don't know what FB is or what CF is, but we know that CB, which is the sum of those two segments, equals 10. Therefore, we have to set up the proportion in terms of entire segment lengths. BC equals 10, and AC, which is the sum of AD and DC, is 5 plus 3, which is 8. And we're setting up the proportion this way. The part of the side we're looking for over that whole side length will equal the part of the side over the whole side. On the left, we have the part of the side is 5 over the whole side length is 8. And on the right, the part of the side is x over the whole side length is 10. We cross multiply. 5 times 10 equals 8x. 50 equals 8x. Dividing both sides by 8 gives x equals 50 over 8, which is 6.25. Example 5. If a man who is 5 feet 8 inches tall cast a 7-foot shadow, how long is the shadow cast by a 6-foot tall man? The first thing we need to realize is that shadow problems involve similar triangles because two corresponding angle pairs are the same. The person and the ground form a right angle in both cases, and the angle between the person's head and the rays of the sun as they hit that head are the same, assuming that it's at the same time of day. Therefore, the triangles are similar without being congruent. The second thing we need to be aware of is our units. We're given the height of a man in feet and inches, but then later we're given the length of a shadow in feet only, and a shadow cast by a 6-foot tall man whose height is given in feet only. Probably the easiest way to handle this is to convert everything to inches. A man who is 5 feet 8 inches tall is 68 inches tall. A man who is 6 feet tall is 72 inches tall. And a shadow that's 7 feet long will be 7 times 12, which is 84 inches long. And what we've done is we've set up a proportion. The height of the man over the height of his shadow equals the height of the second man over the length of his shadow. This is 68 over 84 equals 72 over x. Cross multiplying gives us 68x equals 84 times 72. Dividing both sides by 68 gives 88.94 inches. 7 feet is 84 inches, therefore the height is 7 feet 4.94 inches, or to the closest inch, this is 7 feet 5 inches. Here are some practice problems. Pause the video after each problem And when you're finished, come back for the answer. In practice problem 1, we're told that segment ED is parallel to segment AB. You're asked to solve for X, to solve for CD, and to solve for CB. We're using the same figure for problems 1 and 3. Here are the answers to practice problems 1 through 3. X equals 10. Note that the fact that ED and AB are parallel tells us that the two triangles are similar because the corresponding angles will be similar. We can set up a proportion 3 over 2 equals x plus 5 over x. Cross multiplying gives 3x equals 2 times the quantity x plus 5, which when we distribute gives 2x plus 10. When we subtract 2x from both sides, we obtain the answer x equals 10. Now we're asked to find some side lengths. And the side length of CD equals 15. That's x plus 5, which equals 10 plus 5, which equals 15. The sum of side length CB is x plus 5 plus x. X is 10, so we have 10 plus 10 plus 5, which is 25. Or the other way this could be done is we know that x plus 5 is 15. We add the x, that's 15 plus 10, which is 25. Practice problem 4. A 12-foot flagpole cast a 15-foot shadow. How long is the shadow cast by a 16-foot flagpole? The answer to practice problem 4 is 20 feet. We've set up a proportion. The height of the first flagpole over its shadow is 12 over 15 equals the height of the second flagpole over its shadow x because it's still unknown. Cross multiplying gives 12x equals 16 times 5. Doing the math gives us x equals 20. Practice problem 5 gives us the triangle on the right side below. We're told that segment AB is parallel to segment CD, and we're asked to solve for x. Recall that your hint is which sides are corresponding sides. Here's the answer to practice problem 5. It's 2.4 or 12 over 5. We set up a proportion with corresponding sides so that 3 over x equals 5 over 4. Cross multiplying gives us 3 times 4 equals 5x. We have 12 equals 5x. Dividing both sides by 5 gives x equals 12 over 5 or 2.4. There were different ways to set up this proportion. The important thing is that you are consistent. And if you got the same answer, your proportion was no doubt correct. Practice problem 6. Solve for x. We're told that side length CB, which is the entire segment of the larger triangle on the right, equals 12. And we're asked to find the measurement of BD, which is x. The answer to problem 6 is 5 1/3. Recall that we need to know the entire length of side AC, which we find by adding 4 plus 5, which is 9. We know the entire length of side CB is 12 and that BD equals x. Therefore, we set up the proportion 4 over 9 equals x over 12. Cross multiplying gives 4 times 12 equals 9x. Simplifying gives 48 equals 9x. Dividing both sides by 9 gives 48 over 9 equals x. Doing the math gives us 5 1/3 equals x. In practice problem 7, Charlie stands 6 feet 4 inches tall. At a certain time of day, he cast an 8-foot shadow. If his sister is 5 feet 8 inches tall, how long is her shadow? The answer to practice problem 7 is that the shadow is 7 feet 2 inches long. First convert to inches so that you have all the measurements in one unit. 5 feet 8 inches is 68 inches. 6 feet 4 inches is 76 inches. 8 feet is 96 inches. The proportion will be Charlie's height over Charlie's shadow length equals Jessica's height over Jessica's shadow length. 76 over 96 equals 68 over x. Cross multiplying gives 76x equals 68 times 96. Doing the math gives 76x equals 6,528. Dividing both sides by 76 and rounding to the nearest inch gives 86 inches. If you want to convert from inches into feet, divide by 12. You will get 7 feet 2 inches. In practice problem 8, we're given similar triangles below, and we're asked to find x. Here's the figure for reference. Set up a proportion and solve. We have x over 2 equals 3 over 4. In this case, we set up the proportion so that we had ratios of side lengths where they were part of the same overall segment. And remember, there are different ways to set up this proportion. The important point is to be consistent in how you do it. When we did this and cross multiplied, we had 4x equals 3 over 2, which is 4x equals 6, x equals 6/4, which is 3/2.